Okay, so we're back in this first graph substance file that we made. And we're going to start building our first material in a minute. But before I do that, we're going to take a look just for a couple minutes at these output nodes. And this is where the result of the graph we build is going to get output to wherever it ends up. And each one of them, you can see, has a label. But it's more than a label. They've also been assigned attributes. And it's these attributes that are actually assigning a specific task to this particular output node. And there's a wide selection. And you can actually have more than one. I mean, you can do like really complicated materials that are, like that are going to be nested in something else, and you can have, a whole bunch of these that are extra and masks and whatever output you want. It doesn't have to be just the stuff that you're going to use in a specific material. You can add an output node by right-clicking, going Add Node, Output. You'll also notice that there are image inputs as well. And we're just going to take a quick look at that. Let's find a node here. For example, the pixel processor here. This is an advanced node, but it does have an input image. And when you start creating your own nodes, which you do when you write functions and create materials that you nest, you can create them in such a way that you can, that the end user can input different things into them. So for example, you could have a function and you could input an image and have that function process on that image and then create an output. The other thing, and you can also add different properties as well. So this would mean that it would accept base color and diffuse. I've never done one that's double. The formatting, I've never changed this. This gives your different kinds of color formatting, and then this is your mipmaps. This is your LOD. Again, I've never touched this. I want full mipmaps. I want things to have, to look realistic and to be sharp and all of that, so I'm going to leave that alone. These are the actual attributes, the nodes. So, it's identifier. So this is its unique identifier, and this is its label. So if I had, two base colors, I could say base color material 1 or base color material 2, but it doesn't change what's actually going on here. If we created a material and had outputs that we then dragged and dropped into, something else that we were making, this would be the label that would appear right here. And user data, I'm guessing you can put, well, like notes and stuff in there. Groups, I've never ran into trouble not making, I mean, they should all be the same group. It does look little weirdnesses if you don't have groups, as far as hooking things up and using noodles. And sometimes, for example, if you don't have them all as the same group, if you made a material and tried to hook it up to these outputs, if they weren't all designated with the same group name in here, they wouldn't all come out together as a group. In other words, the ones that had the same group name would come out together, and then you'd have to redo the other ones by hand. So it's stuff like that. And that's about it for the output nodes. It's nothing nothing rocket sciencey. Right. So we are now ready to build our first brick wall. And the reason I say first brick wall is because there's more than one way to build a brick wall. And what we're going to do is we're going to kind of do it a couple times over and keep getting a little bit more complicated with the wall that we build. The first one we're going to do is what actually comes with Substance Designer. And we can come in here into the generators. And this is a group that is native to Substance, and it's available to use in any project that you have. And in here, there's a thing called Brick Generator, which, gives us a brick wall. Right now, we're set, this is showing as 512 by 512 for its size. And that's because it's set to be in sync with the parent size. This allows the end user to scale the size of the output image. And we can change the parent size in here, and it's going to step up with what this says. Now you'll notice here it says parent times 1. there are times, for example, with this brick generator, there's a reason why it's at, 512, is because as the size of your image goes up, or, as the size of the output goes up, the processing takes longer. And there's a bunch of different ways to handle that, but the most straightforward is to reduce the resolution. Now, we could go ahead and bring parent size back down again. You notice that this number gets smaller. So it's 4.17 milliseconds at 512 by 512, and it keeps going up as the size of this image increases. Now, let's say I want to work a material at 2K, but I don't necessarily need this information from the brick generator to come out at 2K, because this is just a very simple gradient mask, really, that's going to allow me to change the size and shape of these bricks. But, 512 will do me, probably. I mean, at worst, at 1K. But I certainly don't need it at full scale. And that's where this parent times 1 comes in, because I can actually change the output size for both the width and the height of the image independently. And I can, for example, bring the width and the height down by 1. So it's saying parent size by half. So instead of being parent size 2K, it's now parent size. It's now like half of that, so it's at 1K now. And if I bring the parent size down to 1K, it's going to be 512, and so on and so forth. So you can actually get this to be much smaller if we're only going to be using it, as a way to get, some bump. But what's going to happen? We're not going to talk about this right now, this transform 2D node right now. I'm just going to use this as an illustration. But right now what's happening is that this node is getting this size information from this brick generator. And it's going to keep passing that size information on unless we do something about it. And that's the second part of this output size parameter. You'll notice that this brick generator is going on a different scale than this transform node. And I'm going to change that here. Right now, this is going relative to input. So for this transform node, it's going to get its output size information from whatever node is feeding it. And if they've got more than one attachment, it's the one that's feeding into the one with the dot in the middle. But I can also switch this to be relative to parent. And what that's going to mean is, instead of getting its size information from what is feeding into it, it's going to always get its size information from what my parent size is. So regardless of what's going on with this node, this will always match up with this if it's set to look at the parent size, not the input size. And then there's a third one here, which is absolute, which I use if I'm like using bitmaps that I've made in Photoshop and I'm incorporating them into my substance material. This creates a standalone size. So I've set this to 1K, and regardless of what's going on around it, whether the parent size has changed or the input size has changed, it's going to stand alone always at this absolute size that I've set in. We'll get to the transform node actually in the next part of the lesson, in the next video. But for now, I'm just going to get rid of that. And I'm going to leave this as a smaller size because it's going to take less processing speed. Now, there are other base parameters that we're not really going to deal with right now because for the most part, you don't really mess around with them except for the tiling mode, which again, bring that in. We're not going to tile quite yet, but it is one that you may come across. Again, right now it's getting its tiling input from whatever comes into it. And I can't change what kind of tiling it's doing. I mean, there's no drop down. It's grayed out. The only place where I can change the tiling attributes of a node is if I set it to absolute. And again, it illustrates the logic behind what we were seeing with the output size. instead of output size, now we're talking, the mode of tiling. The mode of tiling, if it's inheriting it from either one of these places, by definition, you can't change it. So the only place that you can change a tiling mode is if you've set it to absolute. And there are many reasons why you would want to do this, especially when you start making your own noises, like this brick generator. And a great way to learn how to make things is to actually deconstruct what somebody else has built. And any node that you can pull out, any node that is in the library, you can actually see exactly how it's been constructed by right-clicking on it and then going to Open Reference. And it'll ask you, do you want to load the package? You say yes. Now, if you've built it yourself, it's a quick way to double-check to make sure that, it's the actual material you want, or to actually tweak a material if you're incorporating it into something else. If it's something that somebody else built, it's going to be read-only, which it says down here. But you can't change anything, but you can sure learn from it. And I have to say, I probably learned 80% of what I know about Substance Designer by just going into these things and just trying to puzzle it out. And you can keep going, keep going down into this, like each one of these. If there's a reference to open, you can open that reference. And you can actually dig way down into how functions are built and all of that stuff. So I highly, highly, highly recommend doing that. I'm going to get back to our first graph. I went into our Explorer. I'm going to double click on first graph. It's going to bring us back to where we were, and then I'm going to right click here. I'm just going to close these guys out. Let's finish this lesson up by actually making something that approaches the beginnings of our brick wall. So we've talked a lot of theory, but let's actually come in here and see what the end result of that huge graph we were just looking at is giving us. We've looked at the base parameters, and these are parameters that are shared by all nodes, I think except for the outputs. They all have this same thing in this first section. The next section, we can make that a little smaller, are attributes, and this is more about where it's looking like the graph instance, dependencies, things like that. That's not something we're really going to worry about right now. What I want to look at is instance parameters. And instance parameters are something that you create when you create a graph. If it's got any kind of interactivity at all, it happens through instance parameters. And right now we've got nothing as far as instance parameters here, but I can make them. Right now I'm highlighting the nodes. So each node, if I drag down a random node, this is the bad example. We have to grab something from the library. So this has instance parameters, but they're completely different from the instance parameters here because they are specific to whatever functionality is happening in that particular node. And if I double click, left click on my graph here, I can create my own input parameters. And this is a little bit more advanced. We're not going to deal with this right now, but I just wanted to show you that, this is where it comes from. That each graph, anything you create here, has the capacity to have input parameters that can be acted upon via functions. And once you learn how to create functions, then you can, start having your material do all kinds of really wild and cool things. But let's learn how to build a material first. Right, so we're back to our brick generator node. And we've got a bunch of different instance parameters here. Right now I'm going to look at the 2D version of this. If I ever want to have this image fill my screen, I just click on this one-on-one and it'll just automatically fill it up for me. I can tell it how many bricks I want in a particular direction, how squishy I want them. It's got all these cool parameters in here, bevel, all sorts of things. And this is something that has been created with functions inside this giant graph that we looked at earlier. And these are all the toggles that were, the input parameter toggles that were created. So lots and lots of stuff. You can fool around with it. We can offset it. We can do all kinds of cool things. But for now, I'm going to leave this alone. You can play around with it on your own. because I want to build one ourselves. I mean, this is great. It's good to know. I use it often. But right now, we're just going to hook it up to, just see how to hook up materials and get something happening in here. And then we're going to stop this video. And in the next lesson, we're actually going to kind of build one of these on our own. It's going to be really small, really simple. But, we built it ourselves. For right now, I'm just going to plug this into our base color. And even though it's a grayscale, base color doesn't really care. So we'll just do that. The next thing we have here is our normal. Again, we can go to the library and type in the word normal, and it'll filter out anything that has the word normal in it. And there are lots of cool tools in here. And then there's also an atomic node that will create a normal for us. So I can either drag that out like this, or I can right click, add node, normal. The one I wanted to look at in here is actually height to normal. There's a lot of normals in there. And they do the same thing. One of them does the job a bit better and with more detail, but it costs a bit more. So, use the one that works best for you. Sometimes you don't really need all that much detail, and you can use the regular one. Sometimes you need a bit more, a bit more detail. It has to be finer, and then you use the height to normal. So let's see what the difference is. Yeah, that's pretty nice, but it costs more. The regular normal is missing that height, which is why it's less processing. So this, you can adjust the normal intensity. I mean, you can get a really good result with this, and you can go above 3. I mean, you can make it as big as you want it to be. And in this one, you can also adjust the height depth. So it gives you one more thing to adjust. The rest of the stuff, we have a roughness, a metallic, and a height. We're going to leave that alone for now. I'm just going to get just a uniform color. And again, in its specific parameters, I can switch this to a grayscale. And I'm going to find kind of like this 50% gray, and I'm going to apply it to the roughness. And it went from being black. If this is empty, this is reading it as black. There's no information, so it's reading it as black. And you'll notice that if I put in this gray, it's not quite so shiny. And I can change this color. I can I can change this tone. And the whiter it gets, the duller it gets, because the roughness is increasing. So if it's white, it's full roughness. If it's black, there's no roughness at all. And that applies to all of these grayscales. So same goes for metallic. So if we plug this 50% gray into the metallic, it's going to start looking like a metal. And for the height, I'm going to get another one right now that's going to be just completely black, because we are going to deal with that. We're just going to deal with it in a different lesson. But that's actually exactly the same result if I leave this blank or if I put that in. It's just I like to put it in because it reminds me it's a placeholder. And there we are. So we've kind of built this brick material out of this brick generator. And I'd say, we've learned some stuff. And then in the next video, we are actually going to get rid of this and replace it with something that we built ourselves using a couple of new nodes.